teacher. Hello, teacher. We are the second group. My name is Guanjing Ye. I'm pleased to introduce my member. He is Qi Wei-shi, he is Chen Jungu, and she is Yuan Zhulin. Our project topic is using distance simulation modeling voice restaurant process. So, our content is project summary, problem and issue, and the original model, and we prove the new model and the final conclusion. Everyone knows Donghua University Boys Restaurant is renowned in national academic years. Decoration very high. The larger change, which the departments sell many different. So we want to do it for the subject of we hope that the interval and the external. So our project summary simulates the customer ordering process in voice restaurants, and in order to improve the ordering time and shorten the path. The objective of the point, we deflected 3 points. 1. To understand the voice restaurant ordering time and path. 2. To establish the voice restaurant ordering model and path. 3. Analysis and improvement. Next, problem and issue. We want to know when the voice restaurant closed. We want to explore issue which is about how to improve fixed line playing in voice restaurant can become more smooth. Because when closed, everybody cannot to walk and walk very crawling. It is not only to students of the right and the safety, but also can make voice restaurant income be better. Therefore, we will use the simulation to discuss the reason for this problem. We hope teacher teach our simulate. The program can help us improve the voice restaurant. Question 1. Distance issue. Dining table and a chair near each food and a beverage sector that make the students dining comfortably in a restaurant. But when closed, it can be the situation caused by queuing. The queuing is very long, and then the people can not to this side to outside. When students pick up the meal, or when they are closed, and it happens they go to the destination difficultly in the stool. Just a long queuing, you want to go to this side, can be very many people can block the situation. So the situation can be very not good. Question 2. Queuing problem. Customer want to see the situation is caused by the closed queuing to happen. Even if there will be only one store, the occurrence of expected fraud, after all, may cause imposter layer, where there are between the gap and each another may all interfere with each another. Because access will be more closed, it will cause the entry flow system is messy. So when the queen is very long, 就是如果说当外带的人，就是内用的人太多的话，然后就是很多人想要去外带，外带的话队伍会拉很长，因为人很多，这样的话门口就会出入很频繁，出入频繁的话，可能系统就会变乱这样。好，next。
And here is QAC. I will introduce our model. Our objective is to find out if there is a better outlet for this restaurant, so it can make more profit and serve more students. But if we build the model in detail, the model just kind of messy and complicated. So this is the model in the detail. The orange area is the moving part, and the purple color is the KLG fried chicken, and the blue area is hot and ramen, and green area is package, and yellow area is buffet. And the dining area is in a light yellow. So we use simplified model, which is easier to describe and easier to build to understand. We separate the model into 7 major parts: the work entry point and the first to 6th level. So we can see there is 6 lines with first to 6th level. The first point is work entry point, which is the customer entrance. After customer arrives at the entry point, the customer has 4 choices. And the customer arrive time, depending on arrive, the times follow a normal distribution with average 0.157 and the standard deviation 0.132. And consider the customer may come with their classmates or friends, so there comes a batch. So we use batching, which batch size follow normal distribution with average 2.1176 and standard deviation 1.5939. And rounding out, here customer make his decision which food he wants to order. And there is buffet, package, hot pot, and fried chicken. At first level, we use level action to decide the time it takes to walk to each booth. And we calculate the distance into timing, and we store the timing value into a table, then work time to order. And the timing value is based on this distance. And the second level, practice the action walk. This work center will load the label value. So we use label-based distribution and select the label we just set in the first label. And the replicate we set to 999 because there might be many people working at the same time. The third label, the customer will check the waiting line. If the waiting line before the booth is too long, he will change his mind. And remake his decision. As check waiting line work center, we set up a visual logic. If the queue for A booth is too long, then the customer will change his mind. So we set the level changing mind is value to 2. Else, we set the value equals 1. So as a routing of discipline, we choose the label discipline and select the label name change mind. And if the label value is 1, the customer will keep waiting. If the label value equals 2, the customer will change his mind and go to the other booth. So when customer changes his mind, he remake his decision with person discipline. And there is a new choice. The family mart for customers who don't want to wait anymore and get the fast food. The label action resets the time it takes customers to walk. And the fourth level, they'll do the cooking and decide customer is finishing his dishes for here or to go. So we use routing out with person discipline. So if the customer selects to go, he will pass the work time and leave the system. If customer select to for here, and customer will search for a dining area and pass the time he eats. Well, if there is no dining area, the customer will leave the system. For here, the customer will search the nearest dining area with more priority. If all dining area is full, and he will take this dish and leave the system. And to go, the customer walk to exit this level, dining and leave. The customer finishes his dishes and leave the system. So the timing is the time customer finishes dishes, and we set the seed quantity with replicate. and now they will see how customer will act in this system. First, customer arrives and makes his choice. Then he walks, then checks the waiting line. Then there's too many people, he don't want to wait, so he changed his mind to really good and walk through it. Then he checks the line again and wait. So he finally got his dishes. Decided to finish it for here and search for dining area. Finish his dishes, then release system. OK, thank you. 好，改善前分析。这个餐厅现在只有一个大门，它是同时是那个入口也是出口，所以进出人员的效率很差。然后进入餐厅点餐与离开餐厅的人，他动线会重叠。还有摊位距离入口太远，都是在餐厅内部。如果是我今天想要外带，那我还要跑到餐厅的最里面才能点到餐，所以这样是对外带人来说是有点不方便。好，所以第一个在入口进出的人潮，可能就会发生堵塞的情况。还有点完餐跟想要点餐的人，可能也会塞在一起。然后比如说我今天要外带，我还得跑到最里面才能点餐。
So we send boys return their friends. Second, we set up two doors, and the seating areas are near the right order. And meal area are near the left door. Left. So right will become simple. Right come in front the right, and then steaming, and then eating finally from the left door. And we put right a root block the get to the set meal 10.8 meter, change 2.5 meter. The get to the pot 12.6 meter, change 6 meter. The get the KLG 13.8 meter, change 9 meter. The door to the buffet 16.8 meter, change 16.8 meter. And so we look employment before employment. Company job 1081. Now employment after employment, company job 1242. Now before employment, company job 549. Now and then after employment 6,558. Now this is KLG before employment 456. After employment 549. This is after employment
company job 3,083. After employment, company job 5,532. 然后最后我们分析出来结果做个整理是，我们改善之后的结果是，完成的点餐人数变多了，路径减短之后点餐人数变多了，就是图表是自助餐改善那个我们改善南餐的配置图之后，发现改善前人数跟改善后人数就是总的点餐人数增加了100多，就是短短半小时我们只要改善一些就是规划的部分就可以做人数就是会比较快，就是顺畅度会就比较好，对，然后这是我们做的结果。
This is design plan. Before we improve, we find the distance of eating area and to go through the ordering area is far, so leaving some students have to go to leaving some students spend some time to go to the eating area. Another problem. The route of ordering area is not good. Leaving some crowd of students resist ISO that another student have to report. This improvement this design when after we improve. We improve the ordering area be the same size, and then eating area in another size, like a circle. It can resist some time. The difficulties we encounter, because we are not a field personnel, and there are too many students that we cannot make accurate data. 2. We cannot predict students. The psychological, we just only be collected from the field conditions, and the data to judge what they more want to eat when they go to the restaurant. Our conclusion as follows. In this study, based on the data obtained, we analyze the process wasted a lot of time, so we try to use computer simulation software to enable the restaurant to improve the efficiency and effectiveness. This is our analysis of data. This data, we use the steps to measure how long to go to the seat. Finally, we are grateful for the teachers that we have opportunity to learn and to make such a report. The reference. Since our report is search the restaurant in the school, so there are nothing can be consulted, so we measure by ourselves. Thanks for your attention.